Hello everyone, this is Xiaoyu Zheng. I'm a group member from Group 1 in this course, and our course here is Math5800, Financial Data Mining. So this is a very interesting course. I learned a lot from this semester, and now I want to do a brief introduction for myself. I'm a third-year master student here. This is my third year because I enrolled in two programs. One is statistics from the statistics department. The other is the financial mathematics in the mathematics department. So I think I will graduate at the end of next semester. I'm interested in the analytic things using software SAS and R, but now I'm trying to learn more about Python. So if you have similar interested as me, we can learn together and discuss together. Thank you.
Hi, this is Hui Li. I am a graduate student in actuarial science. I took financial programming last year, and I like that course, so I took data mining again this semester. Here, I want to thank Professor Du for giving us professional guidance and teach us programming skills. Also, I want to appreciate the two great group members, Xiaojuan and Xiaoyu. Some homeworks are difficult at the beginning, but after working together and of course on the Professor Du's help, we finished all the homework and project. This course is very good. I will definitely recommend the classmates to take this course in the future. Okay, good luck.
Hello everyone, this is Xiaojuan He. I'm currently a first-year master student at actuarial science major in the math department at UConn. Previously, I obtained my psychology and neuroscience master degree also here at UConn. I have been fascinated by machine learning and data mining for a while, way back when I was in neuroscience major, and I applied some machine learning techniques like k-means, principal component analysis on my neuroscience data. But however, I always wanted to have more thorough and deeper understanding on the data mining. So this semester I'm taking Dr. Du's financial data mining course, in which I learned a lot and applied different algorithms and techniques in analyzing the financial data. At the same time, I have taken the machine learning course launched by Coursera and taught by Professor Andrew Ng, which is from Stanford University, which is also a great course for learning machine learning, especially for applications in fields besides neuroscience and finance. Dr. Du's class also teach a big part on big data. I think this is a very good introduction in applying the machine learning techniques to big data platform. So I would recommend this course to people who are interested in big data and machine learning. Thank you. Okay, so now let's begin with our project presentation. The title of our project is Gradient Boosting Machine Application in House Prices. So in this project, we are implementing the linear regression with multiple variables to predict the prices of houses. We would like to build a model of housing prices based on several housing features, such as the size of the living room, the size of the bedroom, how many bedrooms or bathrooms it has, where year the house is built, and where does it locate. And since those are very important features that determines the prices of the house, we want to predict what price a house with certain features will sell on the market. This helps understand the selling market of houses and set a relative reasonable price when selling houses. So in this project, we used technique or algorithm called the GBM in machine learning. And GBM here is short for gradient boosting machine, and it is a prediction model in the form of an ensemble of weak prediction models, typically discern trees, to build a more stronger model. It builds the model in a stage-wise fashion like other boosting methods do, and it generalizes them by allowing optimization of an arbitrary differentiable loss function. So for the algorithm, it first learns a regression predictor, computes the error residue, and learns to predict the residue, and then it learns a sequence of predictors. So the sum of the predictions is increasingly accurate, and the prediction function can become increasingly complex. Here is the detailed algorithm for GBM. For the input, we have the training set, x, I, y, I. There are n data points in the training set here. And we have a differentiable loss function, L, Y, Fx, and M iterations. So the methodology are listed here. There are 3 steps. The first step is to initialize the model with a constant value. So here showing as f0x is equal to argmin, and the sum over I from 1 to n for the loss function, where here y is updated from 1 to n. And we're trying to minimize the loss function here. The second step is to do a loop over all the iterations 1 to m. And then inside the loop, we have the first step as computing the so-called pseudo residues, RIM. And the pseudo residue is calculated by taking the partial derivative of the loss function with respect to the fx. Then then we fit a base learner HMX to pseudo residues. And then the next is to compute the multiplier gamma m by solving the following one-dimensional optimization problem. So gamma m is divided by minimizing the sum over the loss function and together with the gamma times the base learner HMX. So still we are trying to minimize the loss function, but there is additional term of the residue that we have fitted with the base learner. The next step is to update the model fmx with the previous fm-1x value, and the multiplier gamma m we just computed and times the base learner HMX for each iteration. And then we do this for a 1 to m iteration, and finally we will get a final value of fmx, and that's our output in the last step. The algorithm gradient boosting machine uses a very simple regression to start. Then it builds the subsequent models to predict the error residue of the previous predictions. Finally, the overall prediction is given by a weighted sum of the collection. So using the weak models or weak predictors, we can build a much stronger model in the end. And GBM is a very powerful tool for doing predictions and classifications. So here we are using it to we are using the GBM here to try to predict the housing prices based on the previous features we just talked about.
Hi, this is Xiaoyu. I will continue for the presentation. So this part is the data selection. First, the data we selected is the post-housing selling prices from the King County, and it includes many different variables, such as the house price. This is the most important part that we want to interested in, and we will predict using the model. And we also have variables like the number of bedrooms or bathrooms, square feet of the living room or basement or parking lots, the number of floors, and how good the condition is, like where it is located, which year it is built and revolted, etc. For the second part, it is how we deal with the data. We trained the model on 70% of our data set and then tested on the rest 30% to make predictions of the housing prices based on the model. As the value of the house price is far away from the values of the other variables, to make our model more accurate, we take log of the price as the outcome. Next part, I want to explain a little bit about our codes. So we wrote the code, we wrote the Python code, and we run it on the platform using Spark. So you can see the first part is that we read in and parse CSV dataset into RDD labeled point. The second part in this slide is we split the data into the training dataset and the testing dataset, or the validation dataset. So we will continue for the course. In this slides, the first part here, we built a JBM model with 10 trees. And you can see in our documentation, we also have models with 20 trees, 50 trees, and 100 trees. Then for the last part, it is we print out the MSE and the JBM model. So from the MSE, we can judge if the model is adequate or not. And these slides, we just show a glance of the output. So the first output is that when we print out the test MSE with 10 trees, you can see here the test mean square error, it equals to 0.067 something. So the MSE here is pretty small, so we can see that our model is adequate. And then for the output of the first tree, this is just an example. So that's because if you run the model with 10 trees, you should have 10 different trees. And this is just one example of the decision tree, which is the model. So here comes our result. We can build the JBM model with different numbers of trees as we have mentioned before. Then if we check the test MSE to see whether our model is adequate, the table below shows the corresponding MSE to 10, 20, 50, and 100 different trees. From the table, we can clearly see that as we build more trees, the test MSE become smaller. So when we have 100 trees, the MSE equals to 0.03 something, which is small enough for the table, for the model. That's all for our presentation for the final project. So here I attached the photos of us three. I'm the very left person, Xiaoyu, and the middle person is Xiaojuan. The right person is Huili. Thank you so much for watching our video. In the end, I will show you how we run our code on the School of Engineering HPC cluster. So first, let's open PuTTY. And I've already recorded the things here, load and open. So here I type in my password for my NetID. I've successfully logged in. Then let's open Dr. Du's lecture. Then we copy the module and load it on the PuTTY. Now let's try to open PySpark. This may take several times. We just wait here. So at this time, I want to show my code when it's loading for the Spark. So my code is here, opened the PySpark code for our project. You can see the PuTTY is still running. Okay, here we got the PySpark loaded. And now let's run the code. I will first do the first part to load the dataset. So now everything is done. Next part, to split our dataset into training and test. And then let's do a quick example to build our GBM model with 10 trees, so we need to change the number here correspondingly. This may again take several minutes to run the code. Okay, here the model has done, and let's try to print out the MSE first. So you can see we get the MSE here, and then let's again try to print out our GBM model. Okay, here you can see everything printed out here. That's all for our video. Thank you so much.